doing my internship at Zidio development. Today I'll be demonstrating or just doing a short video on my internship project on speech emotion recognition using machine learning and deep learning, and so I'll be just doing a brief overview of what that entails. So tag along and let's walk this journey together. So today, in my speech emotion recognition project, I'll just be taking us through some of the steps that, as you can see here, that I've used to develop the model. The first step, as we can see, is importing the models, loading the dataset, data analysis with explanation, show web plots and spectrograms, extraction of features, model training, and then we show the output, the end results that is. So let's begin. The right pronunciation, but I found it easy since the data sets were already preloaded into the system, and so I didn't need to again load the data set. So this made my work easier. So that's why I chose to go with Kaggle. And so, as we had spoken, the first procedure that I did was just to import the modules. We imported different modules, like pandas, which enable numerical operations. We also had the NumPy, which enables data analysis and manipulation, and then we have the OS that enables interaction with the operating system, and then we have the Seaborn, which enables data visualization. Then we have matplotlib .pyplot, which enabled plotting of graphs, in other words, using bar graphs, among other things. Then we have librosa, that is enabled us to do some audio processing, as we'll see later. And then I also imported librosa.display that enabled me display the audio signals. Then we have the IPython display, IPython.display, which enabled me to play the audio. Now, once I've imported the audio signals, I would have loved to listen to what I'm playing. And then we imported warnings. This is just to help us filter warnings and ignore the warnings that and ignore some of the warnings. My notepad or my notebook, as Kaggle calls it, the first thing is to create paths, empty paths, which will fill with paths later. So this is just a list, an empty list that will create all will carry all the paths for the different files that we have. Then we have the labels. These are just like names for different files or different the different files that we have. Then we will do a for loops. The first for loop, this one, it iterates through all the items in the input folder. Then we have the nested for loop here that iterates through the content of each individual item in the input folder. Then we extracted the paths to each file in the folder. Then we split each label after the underscore, as we will see. Then we were able to split again after perform another split on each label, retaining the string before the period. So anything that was before the period gets retained. So, and then now we have to append the label so that we finally come up with, and then change the font to lowercase, so that all the fonts for each label comes in lowercase, so that we have a bit of a cleaner output to look at. If I may just scroll so that we see the different paths. Here I've just printed the first 5 paths. As you can see, these are different paths for different tonal vocal tones, where different sentences were said with a fearful voice. So here I've also printed just the first 5 labels, that which definitely will be fear, because fear is our first folder. Then we further created some data frames, because this is important for us to create data frames. So this one creates a data structure, or creates a data structure with rows and columns, so that we are able, as we can see down here, that we have rows and we have columns. So we give each row a name, so each row will carry and what it will carry. So the row named speech will carry parts. So speech, as you can see here, is carrying parts. So the row named labels will just carry the different labels. So these are just the first 5 items in those folders. But if we wanted to print more, we would simply change here, so that we are able to print more. So down here again, we try to count the number of occurrences of observations in each label. So each label, here we have 7 labels for each emotion, to represent each emotion. So we have fear, angry, disgusted, neutral, sad. I believe PS stands for pleasant surprise, happy. So each has 800 files in them, or 800 occurrences of observations, or 800 items in every subfolder that is within the data set. So the next thing we do is to do some data analysis. Here is where we will use a lot of plots or a lot of graphs. So for here, first we plot a figure, or we plot this as a figure. This is the figure we are talking about. We try to show images of the data set, so in pictorial forms, let me say so. So the size is the fixed size, that stands for the size of the dimensions, that is 10 by 6, so 10 in length and 6. So, and then now we use Seaborn to show the number of occurrences in each of the labels. So it is Seaborn that helps us show these numbers that are here. And then also we have each emotion type. It needs to be shown, as you can see down here. We just picked these names from different labels, as you can see here. Then the y-axis will take the count, as you can see here. The y-axis will do the count. The x-axis will do the emotion type. Then now we show the whole we now have to print the whole thing. As you can see here, we will be able to print. Then now the next step is to show the web plot and spectrum, as we had seen earlier in our summary. So here what we do is we create web plots and summary and spectrogram functions. First we import librosa. Of course, you had imported librosa display up there, but I think maybe I made a mistake importing again, but there's no harm importing again. So this imports packages for audio and music analysis, which basically is what librosa is about. Then we now create the function using the syntax for Python, because we are using Python. Simply creates that function, as I've said. Then again, we create a figure with these dimensions. Then we give it a title. Then we print out whatever we need to see. Then again, we repeat the same process, but now with spectrogram. The other one was waveform, wave plot or waveform plot. That's just the name. What we'll do here is we will showcase. This is just a function that will showcase the spectrogram. So for the x-axis, we'll show signals in time, frequency, domain. We will show amplitude, and then convert signals to decibels. then we have we'll plot the figure that will show the method. This method creates a figure diagram with the set parameter. So it picks these parameters and creates a diagram or a plot for us. Then we plot the title, which is emotions, and Libros a display displays a spectrogram using chromogram. In other words, chromogram is just to show different colors based on different emotional variations. So we'll see that areas that the emotions are high are more red compared to areas that emotions are low, which will be more blue. So these ones are just for different. The next thing for us is just to implement the wave program function for each label or for each emotion. So like for example, the first one we do for fear, as we will see here. And then now we basically that's what this is all about. It's just creating just demonstrating or displaying the wave plot and the spectrogram functions for each emotion. So for fear, there we are with our spectrogram, and then here we are also with our chromogram, which shows, as you can see, where emotions are high, it's red, more red. Where emotions are less, it's more blue. It just follows the pattern that the spectrogram has shown. So this is just used for playing. The next thing that we need to do, since we've been able to print, or rather to showcase for each emotion, like here now after anger we have disgust, as you can see, and then we have neutral, as you can see for neutral, then we have sad, as you can see for sad, the emotions are low. The pleasant surprise as well, happy, and then now the next thing we need to do is to extract features, because now we've just displayed what we wanted to show. Yeah, we've only displayed what we wanted to. In other words, we've just visualized the different items in our data set. So the next thing is to extract the features, and we'll use different features. We'll use one of the functions found within Kaggle that is used to extract. So we'll extract using mfcc. So this function helps us extract a feature of an audio signal. Then again here we'll use variable sample rate that contains the sampling rate of y. So we will show the sample rates, different sample rates, and then now extract. We'll come here and then and now compute the average, you may see, of a given row. So for example, if once we've extracted, we now find the mean, which is simply what this method here does. It helps us find the mean of whatever is on that row. So in other words, for example, everything that is under fear, under the subfolder fear, this is basically what it does. It extracts all the features, then it gets a mean for all those under fear. Then that's what we'll use to train the model. Yeah, so basically this here returns this. Yeah, so this is just in an array format. We implement the extract MFC function that is created below, so above rather. So this function is implemented here. So that's the output for that function. So here again we use this method to return extracted features from all the audio files. So like here we use lambda to do some pre-processing, which will use one hot encoder that will help us do some pre-processing before we are able to train the data set. So in other words, what pre-processing means is that we will take every other type of data structure and convert them into numerical ones, because that is what the computer is able to understand. Then now we will train our data set. So for training, we will have to import sklearn models. One of the models we use is sklearn model selection, which we'll use to train the model. So this is just the model sequence in a sequential way. So this is just what the model will show in a sequential way, how it will progress and show the total parameters that have been used, the trainable parameters and non-trainable parameters. In other words, non-trainable parameters are parameters that are not useful to the model. As you can see, all the parameters that we have can be used, but none has been dropped. So model training, we need to first convert our arrays to float, which is basically what these different methods do. And then now the next thing is to start the training. So we can use different models or different modules to do the training. There are many different modules to do the training. So the history method here is just for you to be able to track the progress of how the model is learning and how the model is able to adjust to changes, to improve in accuracy, and also and just how to monitor how the model is able to deal with the losses. So epoch is just a list number of times the passing this is just a list of number of entire passings of the training model through the algorithm. In other words, when the training model goes through the algorithm, you are able to showcase that through the epoch. So each, as you can see here, I used 50 epoches or epochs. So every time one does that, it records and it displays. So accuracy, this is just a percentage of the correct classifications that the training model achieves. Value accuracy, this showcase it shows the accuracy of the predictions of a randomly separate validation set after each training period. So after each training period, it shows what is accurate, accumulatively accurate in a while. That is what it simply means. In other words, what has been validated as accurate. Then now we plot down the results, which we will see when now we are able to showcase the work. So for me to be able to display my work, so let me start from the top again, so that I need to execute each code so that I'm able to ensure that everything is working. So from I have to execute from the very top, so that I'm assured that everything is working well. So I'll simply just run them all. As you can see here, I'll simply just run them all. You can see most of these ones have been executed. Yes, as you can see here, this one has been executed. If you point against, you see it shows the number of it shows what has been executed and the amount of time it has taken. Even the plot has been executed, and now we are able to visualize the plot, and we are also able to visualize each we are able to visualize each emotion as it has been done once the execution is done. So some of these are still executing, like you can see this is spinning. This simply shows that it is still executing. Some of these are long, and so it will take a while before they properly execute, but once they execute, so it will not be able to execute everything that I have hashed out like this. I had hashed out this, so you will see that once this finishes executing, it will jump to this, because this code, I didn't really think I needed this code, so that's why I've simply hashed it out. Yeah, so we just wait. And then I'll be back once everything is done, so that the video is not long. No error, there's no warning, meaning possibly I may have done a good job, but it is what will become at the end that will prove that I've done the right job. So like here now, we are simply running through each epoch to identify the accuracy, and you can see we are 1 out of 50. This is a bit slow because I'm using my own CPU. I'm not using my computer's CPU. In other words, I'm not using the GPU that is provided for, which is a bit slow. As you can see, I'm not able to access. I'll try find the reason why. I think it's because this one is running already. So so that I don't bore you with this boring process, because it's a very boring process, I'll simply come back. So as you can see, the model has completed the training, and as you can see, the accuracy has gone up to, let me see, the highest is 0.9 9917, which is very close. 0.9926, we have a 0.9926. I think that's our winner. Yes, that has to be our winner, because the model has grown well. This is close to 1, and now we have our accuracy, which at some point the accuracy was at 1.00, which is 100% validation accuracy. And now time to plot the results, so that we are able to see the results and what we have for the results. Let's plot this so that we can see. As you can see, the model has improved. The blue line simply shows the trained model, then the red one the trained accuracy, then the orange one shows the validation accuracy. So it means that when we were starting, they were not very close, but as time went, they became closer and closer. And we can also plot the loss, which is basically looks more like an inverted version of the trend of the accuracy. Yeah, so same with the loss. There's not much loss here. So thank you guys. That's just what I was able to do. If I can scroll from top again, so that you're able to see the whole code and how it looks one final time. Yes, that's it. That's it. That's it. That's it. Yeah, so basically that's it. Thank you guys. I'm still new to this, so I'm still learning. If you notice any mistake in my code, or any way that I can improve my code, please let me know in the comment section. I'm still new, very new to data science, and so it's a learning process for me. I've started small, step by step. I'll keep posting whatever I've been able to do. Otherwise, stay blessed. God bless you.